In this lecture, we'll do derivation for the Compton scattering. In Compton scattering, high energy X-rays are made to strike a paraffin block, and we measure the frequency of the scattered X-rays. We find that the wavelength is high or the frequency of the scattered X-rays is wrong. This phenomena of scattering by when X-ray is striking the paraffin block is explained in the terms of particle nature of the X-rays and the photons. That is the photon. The particles are the photons having zero rest mass, and we also take elastic collision between the photon, incoming photon, which is part of the X-ray, and the electron. The collision is elastic, perfectly elastic, and that is using that concept of elastic collision, conservation of energy, and relativity mechanics will try to arrive at the derivation. Now, before I move further, we will have to recap a little bit of the relativity mechanics. We know that mass of the particle is rest mass divided by 1 minus v square upon c square when the speeds are comparable to the speed of light. Here the speed of electron after colliding with the photon will be very high. It is comparable to the speed of light, so that is why we have to take the mass of electron in terms of this relationship. Now I can further use this relationship to write the momentum of the electron, which is m0v upon 1 minus v square upon c square under root. I square both the sides like this and I get like this. I multiply by c square, I get like this. So I get p square c square is equal to m0 square v square c raised to power 4 upon c square minus v square. I add m0 square c raised to power 4 on both the sides just to simplify it further, and what finally I get is p square c square plus m0 square c raised to power 4 is m square c raised to power 4. When I solve it, I get m square c raised to power 4, where m square is m0 square upon 1 minus v square upon c square. I am not doing that to save the time, you can check it. This is nothing but the total energy, square of the total energy. So in case of photon, the rest mass is 0. So m0 is 0. So photon energy is equal to Pc in terms of momentum. So the momentum of photon can be written as energy upon C, and energy here is h mu of the photon. So it is h mu upon C. The photon's momentum is written as h mu upon C, and here it will be h mu dash upon C. It is going at an angle theta, and electron is coming out at an angle phi. And this is the relationship we'll be using further later on also, so let me retain it. Another relationship which we need to use is the electron will have kinetic energy, but in relativity mechanics it is not the kinetic energy which is the total energy. The total energy of electron is kinetic energy plus the rest mass energy. This is how you have to write in case of electron moving at very high velocity here, and E is nothing but mc square again, so it is Ek plus m0 c square. So these equations I'll be using. Now let me remove it, I don't need it anymore, and let me write the conservation of energy and momentum here. I'll do it speedily so that I save time. So energy conservation is h mu dash plus kinetic energy of electron. Initial energy of photon is h mu, final energy of photon is h mu dash, and this is the kinetic energy of the electron. And the momentum I will write as h mu upon c along x-axis is h mu dash upon c cos theta plus p cos phi. This is along x-axis. Along y-axis there is no initial momentum, so it is h mu upon c sine theta is equal to p sine phi. I can write this here, or p cos phi is equal to h mu upon c minus h mu dash upon c cos theta. I remove c from here and take it here. I square and add both the equations separately. I square and then add them. So I get p square c square is equal to h mu whole square plus h mu dash whole square minus twice h square mu mu dash cos theta. Let me rub a little bit of this space. So I get p square c square is equal to h mu dash. This one relationship I have got. Now ek I will write as ek can be written as h mu minus h mu dash. I square it and I write ek square is equal to h mu square plus h mu dash whole square minus twice h mu square mu dash. I subtract these two equations. I subtract, so I get p square c square minus ek square is equal to twice h square mu mu dash 1 minus cos theta. Now p square c square minus ek square, I can write ek square here as, if I square it, I get ek square here as m square c raised to power 4 plus m0 square c raised to power 4 minus twice m0 c raised to power 4 is ek square. And ek square I can replace mc square here, m square c raised to power 4 by this. So I write p square c square. This becomes twice m0 square c raised to power 4 minus twice m0 c raised to power 4, or ek square is coming this much. Now I add these two equations. So this gets cancelled and this gets cancelled, and I finally get twice h square mu mu dash 1 minus cos theta is equal to twice m0 c square into mc square minus m0 c square. This is nothing but ek. mc square minus m0 c square is ek, and ek is h mu minus h mu dash, so I write it here as twice m0 c square h mu minus h mu dash. So I get this relationship finally, and this is almost done now. The steps have to be just slightly carefully done. I divide both the sides by mu mu dash. This 2 is getting cancelled anyway, and h is also getting cancelled. So I get h 1 minus cos theta is equal to m0 c square 1 upon mu dash minus 1 upon mu. This will become h 1 minus cos theta is equal to m0 c lambda dash minus lambda. Because I have used this relationship, c is equal to lambda mu, or 1 upon mu is lambda upon c. 1 upon mu dash is lambda dash upon c. I have just replaced here, so I get this relationship. Finally is lambda dash minus lambda is coming as h upon m0 c 1 minus cos theta. This is the relationship between the wavelength of the scattered X-ray at a particular angle theta. At theta is equal to 90 degree, you get lambda dash as maximum, because the maximum value of at theta 90, yes, at theta is equal to 90 degree, you get lambda dash minus lambda is h upon m0c. So this is the relationship for the Compton scattering.